I was checking out the recently released A Plague's Tale Requiem, which is on the Xbox Game Pass for Windows, and was blown away by how gorgeous the game looks, especially on an OLED. With new graphics cards releasing now, I thought it would be interesting to check out what developers are cooking up that will push the graphics fidelity envelope, particularly when it comes to realism. So today we'll take a look at a few upcoming games that will do their best to melt your RTX 4090. Oh right, you don't need to play games for it to melt, you just need to plug it in. Today's video is sponsored by urcdkeys.com. If you buy a retail Windows 10 key, you will probably spend $100 or more. But if you buy an OEM key using a service like urcdkeys, it will be less than $15 after you use the coupon code C25. The keys work globally, and if you want Windows 11, what I recommend you do is just buy Windows 10 and get a free upgrade while you can. Personally, I use Windows 10 Pro. Once you've made your purchase, using a variety of different payment options available, you will instantly find the key in your purchased orders on the website. Click Get Keys and copy the key. Then, after you've installed Windows 10 Pro, of course, in Windows press Start and type in Activate and click on Activation Settings. Then click Change Product Key, paste in the code and click Next. That's it. Quick and easy, and your Windows is now activated. If you need Office 2021 Professional, you can use the same 25% discount code C25 and get it for just $59.98. Since you're over there, check out the back-to-school sale of 50% off of PC peripherals like gaming mice, chairs, headsets, and a slew of cool-looking mechanical keyboards. Thank you to URCD Keys for sponsoring today's video. Click the links in the video description to get your OEM Windows keys today. So first up, I do want to encourage you to check out A Plague's Tale Requiem, especially if you already own the UX nightmare that is the Xbox Game Pass on Windows. The game is very linear to the point where it feels like an interactive movie at times, but if you want to take a look at the state of the art in graphics in current games, then it's a great showcase. Here I'm running it on the Ryzen 7950X, which will be featured in an upcoming video very soon, along with the RX 6900 XT, and the game runs great at 4K native, staying above 60 FPS on the highest settings with a few tweaks here and there. The key component here, however, is the display. My trusty C9 OLED running at 120Hz really takes graphics to a whole new level, and it's still an unrivaled experience. It used to be the case that when I recommended viewers get an OLED, people would talk about burn-in. As always, internet keyboard warriors will passionately vomit nonsense that they have no practical knowledge of in your face, even if they're repeatedly proven wrong. And I expect that to be the case yet again, but probably to a lesser extent. I think OLED technology has proven itself, and if you are still on the fence, let me tell you that you should 100% prioritize getting an OLED TV that does 120Hz, either new or used, above upgrading your GPU to a 7000 series AMD or 4000 series Nvidia card. I've covered some of the key technologies that make these realistic graphics possible, but I think they're worth revisiting. To achieve the realistic facial expressions, the French studio Asobo used facial motion capture. This involves strapping a complicated head-mounted rig to the actor's head and capturing their facial movements. I foresee this being replaced with artificial intelligence-driven techniques in the not-too-distant future. Nvidia recently introduced its Omniverse audio-to-face technology, which creates realistic facial expressions and lip sync from a speech audio file. An alternative to this is Faceware Portal, which uses neural net processing to transfer video of a person's facial expressions and speech into a 3D model. Another technology that makes Plague come to life is Quake Saw Megascans, which since the last time I covered it has been acquired by Epic to add to its Unreal Engine ecosystem. The photogrammetry of megascans are so realistic that the developers didn't need to create them by hand, rather just place them in the game world. You can see some of the plants, trunks, and rocks, among other things, used in the game in the Quake Saw website. Also note that the game doesn't use ray tracing, at least not in the current build, so that goes to show that you don't need ray tracing to achieve realistic lighting, if you didn't know that already. Ray tracing will certainly be helpful someday when it doesn't come at the expense of performance, which is still the case even with the RTX Burn Your House Down edition. There are games where I think ray tracing can make sense in the current gen. We'll look at an example of that in a minute. For global illumination, Requiem uses its proprietary in-house technology, and on that topic, AMD has recently published a paper on its open source global illumination technology that already exists in a limited form in Unreal Engine 5. In addition to being more lightweight than current solutions and requiring less GPU resources, it seems to benefit from a lot of cache on the GPU. Not a surprise considering the direction AMD is taking when it comes to hardware. Before we move on to upcoming games and some really cool uses of new technology, I want to quickly mention a few projects that, while not necessarily games, or at least announced ones, give us a glimpse of the sorts of graphics we will be seeing soon on the PC. Something that caught my eye in the search for ultra-realism was a short clip from game developer Alexander Spindler of a bodycam style shooter in Unreal Engine. You'll have to excuse the low quality video, but it's taken from Twitter, which heavily compresses video. The game seems to be using Unreal Engine 5's global illumination to great effect. The environment looks super realistic, even with this low quality footage, and I like the idea of a bodycam shooter using a VR headset, which appears to be what the author is using to play the demo. There's no information on the game or when it will come out, but I'll link to the author's Twitter profile in the video description so you can keep up with the development. Another really stunning showcase is the Luminescent project, which comes from developers Roto Entertainment. Using Unreal Engine 5's Lumen and Nanite technologies, along with photogrammetry, Roto created a vlog-style demo of someone who got lost in the middle of a mysterious island cave, the demo being shown as if it were captured using a mobile phone, hence the vertical video early in the demo. In addition to looking absolutely stunning, I think one of the things that makes this look so realistic is the cinematography. I don't know how well this will translate to games where mouse and keyboard movements kind of remove the sense of realism no matter how awesome the environment is. Nevertheless, at least this level of graphical fidelity is something we can expect in upcoming games. It should be noted that this demo was made in a single week. From Epic themselves comes a collection of ancient Japanese environments running in Unreal Engine 5. While not necessarily a game, these environments use assets that are currently being used in upcoming games. The global illumination here really stands out. I love the reflections on these puddles. It's crazy to think this is running in real time and really showcases what we can expect to see in the near future. Another impressive VR demo comes from Raga029 on YouTube, who created a Hong Kong alley in 4 days using various Unreal Engine 5 tools along with megascans. The ultra-realistic environments again show what's possible with UE5. I'll put some links in the description to the author's YouTube channel where you can find other demos. And before we move to actual games, I just want to shout out Epic's incredible demo called 90 Days in Unreal Engine 5, where their artists created a variety of environments in 3 months. Some really stunning work here, and I can't wait to see games that look like this. Now on to actual games. The first one that looks very impressive to me from a graphical standpoint is codenamed Project M, coming from South Korean developer NCSoft, known for the Guild Wars games and other MMOs. Project M is built on Unreal Engine 5 and features really stunning realistic graphics. Much like playing Requiem, this looks like more of an interactive movie than a video game, which I'm not a fan of. The game character models look great, that's for sure. The developers used photogrammetry from real-world locations in South Korea to create some of the environments. The motion capture looks great also, and on that topic, a paper recently released by Guy Tevitt and his team of researchers presents a human motion framework called MDM, which supports text-to-motion generation for humanoid characters. This AI-based framework creates multiple different realistic outputs keywords. So when you type in "a person kicks," it will generate different results, which is what you'd expect in the real world. I could see these sorts of frameworks gradually being added to game engines to speed up game development massively, all the while producing much more realistic results in-game. Next up is Layers of Fears, the sequel to Layers of Fear. Coming out in early 2023, Layers of Fears is described as a first-person psychedelic horror chronicle that focuses on exploration. It's built on Unreal Engine 5 and uses real-time ray tracing and Lumen. Not much has been shown so far, but the lighting and particle effects look very impressive. And this is the example I wanted to talk about where real-time ray tracing makes sense to use, since the play is traversing narrow corridors instead of a large open-world scene. Ray tracing won't be as taxing on the GPU. These are the sorts of games where I can see it being used without destroying the experience. Speaking of ray tracing and particle effects, developer Niels de White at Agniflare showed some really cool particle effects in Unreal Engine 5 using Niagara. What makes these so cool is how they realistically bounce off the geometry in the environment. The next game that looks set to melt 4090s is Atomic Heart, which, if you remember, was featured all the way back in the RTX 2080 Ti presentation and has been regularly featured on Nvidia's YouTube channel since 2018. The game has certainly evolved from a tech demo to a game that looks very impressive at times from a visual standpoint. In addition to some impressive particle effects and lighting, the gameplay actually looks like a ton of fun. On the game's website, you can still see the RTX logo, so this is clearly an Nvidia-sponsored title, which means we'll see ray tracing featured heavily, and probably the devs will push the junk that DLSS 3 is. The game is built on Unreal Engine 4, so we won't see some of the UE5 technologies, but from the gameplay revealed so far, this looks to be a game designed from the ground up to make good use of ray tracing. We'll see if it can be the title that makes ray tracing worth turning on. The game is set to release before the end of this year. Next up is Crimson Desert, which is being developed by Pearl Abyss from South Korea, running on their own engine. It's a fantasy open-world RPG that has some Witcher 3 vibes. The thing I find impressive about this game is the sprawling vistas with a stunning global illumination system and the sort of ray marching technique we saw in Red Dead Redemption 2. Speaking of The Witcher 3, Crimson Desert seems to employ some hair tech similar to Nvidia's Hairworks. On a side note, 3D character artist H64G on Twitter created a hair system with Unreal Engine 5.1 MetaHuman that renders physically realistic individual hair strands. It's not perfect, but it's one of the best techniques I've seen, and assuming it's not excessively taxing on the GPU like Nvidia's Hairworks was, it could add another layer of realism to character models going forward. Back to Crimson Desert, the particle effects during combat look really incredible. You can tell the GPU is struggling to render this at a decent frame rate, so maybe if the game is actually good, it will be a somewhat valid reason to purchase an overpriced high-end GPU this generation. Next up is Callisto Protocol, which will be out on the 2nd of December, so just over a month from now. It was made on a custom version of Unreal Engine 4 with some technology from UE5 thrown in. Looking at the gameplay shown so far, this is evident in the use of older tech like screen space reflections. So ray tracing is used exclusively for lighting and shadows. Even though this is on an older engine, there's some interesting tech being used here, like how the character bodies are made of interlocking meshes, so melee hits and shots from guns have a realistic impact and affect the character models in a way that's believable and feels very visceral. So visceral that the game has already been banned in Japan. The game also has some of the best subsurface scattering I've seen on the characters' faces. These are in-game scenes, they're not pre-rendered. I gotta say I have high hopes for this one. Next is the First Descendant, which is another game built on UE5. This is another game coming from South Korea. From the trailer shown at Gamescom, you can see the use of both Lumen and Nanite in this desert canyon part. The global illumination looks fantastic, as do the particle effects. The post-processing of these new upcoming games is the key ingredient to making them look so good. There seems to be ray tracing involved in some form, judging by the reflections on the shell of this boss monster, but to what extent is unclear. As for the game itself, it looks incredibly generic, like just another Anthem or Destiny 2 sci-fi shooter. Senua's Saga Hellblade II has been hyped up to the moon, and the gameplay reveal seems to confirm the graphical prowess promised in the early trailers. The moody lighting and cinematography that blends gameplay and cutscenes into one is some of the best I've seen in a video game and really sets the mood and tension. I wasn't a fan of the original, it felt clunky and the protagonist was kind of annoying, so I'm not sure I'll pay too much attention to this one beyond the technical aspects when it finally comes out. One thing we see in the gameplay trailer is UE5's realistic terrain physics being used. In this scene, where the giant dislodges itself from the rocky face, shows rocks breaking apart and colliding with the environment in a realistic way, similar to what was demoed by Epic last year in their Meteor demo, which uses a voxel plugin. These are the sorts of technological improvements that marry greater graphical fidelity to actual gameplay. The one thing that worries me about Hellblade 2 is that the gameplay seems to be running at 30 FPS. These graphical advancements don't come without a performance penalty, especially on consoles. Fortunately, on the PC you can always lower settings or use FSR or DLSS, assuming those will be available. Speaking of which, one technology from UE5 that's kind of been forgotten is that upscaling tech, TRS. I did find one upcoming game that has talked about using it, although there's not much info on the game itself. Legend of Ymir is being developed by South Korean studio We Made Entertainment, and it's a sequel to Mir 4, which apparently is a popular MMO in Asia. Legend of Ymir makes great use of nanite with some very complex models like this throne being easily rendered in real time despite its complexity. It's curious to see an interest in high graphical fidelity in games that are typically played in internet cafes in Asia, and while this isn't the most impressive looking game of the bunch we're looking at today, that's a result of the sort of concessions developers have to make in a game like an MMORPG that has to run on lower end systems. It's still a testament to how well UE5 games should scale across a variety of system configurations. The use of TRS upscaling will also help with that. Next up is Shadow of Conspiracy Section 2, a terrible name for what looks to be like a cross of Metal Gear Solid and Crysis. This is yet another UE5 game, in this case with way too much camera wobble for my liking. I don't know about you, but I get motion sickness very easily. Besides the realistic looking graphics, the things that stand out to me are the overall contrast. I can see this looking great on an OLED, and the liberal use of post-processing effects like lens flare, J.J. Abrams style. It's not something that suits every game, but it seems to really work great here, especially in the way these effects reflect off of the weapons. This is early in development, but it's a nice showcase of how UE5 can be used for more than sprawling desert scenes. And the last game we will look at I was a bit reticent of covering, and that's Avatar Frontiers of Pandora. The reason being, I can't tell if what Ubisoft has shown so far is in-game footage or pre-rendered. The studio released a tech showcase talking about the new features added to the Snowdrop engine, so one would assume this is all in-game, but if you remember the original The Division E3 showcase several years ago, you know that Ubisoft has no problem lying to gamers and presenting game footage that's not representative of the final product. But then I thought that if I do cover it, and it turns out to be bullshit, and the final product doesn't look like this, then maybe you can join together in calling Ubisoft out on their BS. If the final game does look like this, then it's mighty impressive. The developers talk about ray-traced global illumination, a volumetric cloud system, along with ray-traced reflections. One of the interesting technologies here is the use of automated placement for vegetation and the move of visibility testing from the CPU to the GPU, which will allow for the processing of a lot more objects per frame. If you've watched my recent reviews of the Zen 4 CPUs, you know that we're reaching a point of stagnation when it comes to CPU performance's effect on gaming, and with developers moving more of the workloads to the GPU, this will only be accentuated further in the future, with CPUs becoming more and more secondary to gaming performance, even in open-world games like this. Processing these cores on the GPU means you can have a lot more detailed environments, and Frontiers of Pandora seems to showcase that really well. So these were a few examples of upcoming upcoming games that could maybe be a reason to upgrade your GPU to the latest generation. If you are a patron and go to the latest video discussion tab in the Cortex Discord, you can find several more examples of upcoming games that will push graphics to a new level. I know I've said this a million times, but if you really want to take your gaming experience to the next level, then a good display is for sure your #1 priority, and nothing beats OLED right now. If you do decide to get an OLED, then check out the video description for some affiliate links, which will help out my channel. I will have a review of the 7950X up on the channel very soon, along with my thoughts on what's next for CPUs now that we're reaching stagnation, so be sure to subscribe so you don't miss that. This video was made possible by my awesome patrons. Join my Patreon for just $1 per month and get exclusive access to the Cortex Discord server, where I frequently share exclusive bits of information. If you can't contribute financially, then please give this video a like and share it, as that really helps. Thanks for watching, and until the next one.